Okay, so today we'll be doing functions.
Where's the class 3 attendance?
Oh, sorry?
Where's the class 3 attendance?
What do you mean?
Like, whenever we come here, we have to take a screenshot and put it in the classroom.
Oh, are you taking like another class from Lovelace?
No, like, that's where, like, usually they post attendance.
Yeah, I'm also taking another class, and I don't know, she said it was like this new attendance policy, and you have to like post a screenshot to show you were like actually in the meeting.
Oh, what class are you taking?
I
I'll
was
ask.
taking geometry yesterday, and that's what
Yes, same.
she told me.
Okay,
Mm-hmm.
I'll ask them later, but I don't think they said to have me do that yet.
Okay.
Yeah. Mhm. Okay, so today we're doing functions. Functions 1, there'll be like parts 2 and maybe 3 later. Okay, so hopefully you guys all have like some idea of what a function is. It's just like a machine. You have like one input and then you get one output. For every input, you get exactly one output. So for like different inputs, you can get the same output, but for every input, you can only have one output. You can't have like two or more outputs. Actually, the definition of a function is like a lot broader than you might think. They can like map anything to anything, and it doesn't necessarily have to be like a mathematical function. Like, and it doesn't necessarily have to be graphable either.
Wow, we're gonna deliver pizza sauce now. Putting a picture in.
Sorry. Um, yeah, so they don't have to be continuous or graphable or mathematical. For example, you could just have a function, and then you like give a number and then it can output like the population in America, that's that number's age. Like it doesn't have to be mathematical, right? And then in this class, we're mostly gonna look at like polynomial functions, but yeah, there's definitely a lot of different kinds of functions. So a function, there's two main things that's really important about them. It's the domain and range. So I don't know if like in other classes you guys use like codomain or range before. Many classes view them as like in this like the same, interchangeable, but there's actually like a pretty big difference, especially if you go into like higher maths or like higher polynomials, there is a pretty big difference. If you're only looking at polynomial functions, it's usually the same, but yeah. So the domain is like the set of possible inputs or like x values if you can graph the function. Not all functions are graphable, but like the ones we look at usually are. So for example, if you just have the like linear function fx equals x, then the domain is like all real numbers, right? But these like other integer sets are also pretty common domains, and they're usually denoted by these like fancy uppercase letters, like fancy R or fancy Q. So if you just see that, like these corresponding sets are what they mean. And then you can also have domains that are not real numbers. Like if you guys know what complex or imaginary numbers, you can also have those kinds of domains, but we won't be looking at them. And then codomain is a set of possible outputs versus range is the set of outputs actually reached. So if you have a function like fx equals x, then the codomain and the range are the same. But if you have a function like fx equals x squared, then the codomain is still all real numbers, but the range is only the like non-negative real numbers, right? Because x squared can't be negative. So that's like where the difference comes in. Does that make sense? So usually a function is specified by its domain and codomain, and then you have to actually look at what the function is to find the range. So for example, a function, so what would the codomain, domain, and range be for the function inputting a state and outputting the population of the state? You guys can just like unmute and say it or put it in the chat if you want. Yeah, okay. Well, basically, the input would be like the set of all possible like states in like the United States, right? So the set of like 50 states. And then, so the codomain would be like all non-negative integers because you can't have like half a person and you can't have negative population either. So it'd be non-negative integers. And then the range would not be all of them, but only like the 50 numbers that are reached. Does that make sense? And then for fx equals x squared, the domain would be all real numbers. The codomain would also be all real numbers, but the range would only be the non-negative integers because you can't have the negative x squared. Okay. So composition of functions is when you combine two functions. So if you're given like two functions, fx and gx, then this notation with like the f circle gx, or you can just write f of g of x, it means the same thing. Basically, you first take the inside function, the gx, and for some x, gx will give you some y, right? And then you take f of y to get z. So the result is z. So yeah, like in this diagram, you have x first, you put it in the like machine G, and then you get an output, and then you take that output and you put it in machine F. I know this is like, it's really important. This order is not interchangeable. Like f of g of x is not the same as g of f of x, right? And so when you do a composition of functions, you have to be careful that like if you get some g of x for the input x, right? You have to make sure that g of x is in the domain of f. Because like x might be in the domain of f, but g of x might not be. So you have to be careful that these functions are combinable. Yeah, if you guys ever have any questions, you can just unmute or put it in the chat. So we have an example here, right? So if you have a function taking the state and giving the population, and a function taking the population and giving the number of houses needed, then you can combine these functions because the range of the first one is the same as the domain of the second one. And then so you can take a state, say like New York, and then it'll give you the first function will give you the population, and then you take the result of the first function and you put it into the second function to give the number of houses needed. So when you combine these two functions, you get a function taking a state and giving the number of houses needed in that state. Does that make sense? And then in this example, I think it's pretty obvious why these aren't interchangeable. Like you can't have the function taking the population and giving the houses first, and then plugging that into the one taking a state and giving a population, right? Because the first one is combinable with the second one, but the second one isn't combinable with the first one. So order like definitely matters. And then if you want like a more mathematical example, if you have fx equals x plus 2, and then gx equals 3x, you have f of g of x is 3x plus 2, right? Because if you have some x, and then you first plug it into g of x, then you get 3 of x. And then you plug 3 of x into f of x. So 3 of x is the new x, and then you get 3x plus 2. But if you do it the other way, if you do g of f of x, then you first take f of x for some x to get x plus 2, and then x plus 2 is the new x. So when you plug in g of x plus 2, you get 3 times the entire x plus 2. Does that make sense?
Yeah.
Okay, great. So for these two, do the domain and range change? And you can just like unmute and answer if you want. Okay, yeah, so for these two, the domain and range are both all real numbers, so they don't really change. But in the first example with the state and the population, they do change, right? So just be careful of that. And then if you guys don't have any questions about them, then we can go over some practice problems. So do you guys want like quite a few minutes to go over these? And then we can talk about them, and especially the last one, you guys can just put your answers in the chat if you'd like. And I'll give you like quite a while to do them. Oh yeah.
Hello. Um, Hi. Yeah, I talked in the beginning of the class about my attachment issues, right? I
Yeah.
sent you the email with my homework. Can you check now?
Oh yeah, I got it. Thanks.
Okay, thank you.
Yeah, I'll check that later. It's about like 9:32. Do you guys need a bit more time for them? It seems like you might. Oh yeah, I'll give you guys quite a few more minutes. I think I went through the lecture notes quite fast, so we have a lot of time. Okay, I think we can start explaining the problems. Okay, so for number one, I think, yeah, I didn't really specify a lot of stuff, so don't really worry about it. I should have said, so for X is in terms of years, so X is like a whole number of years, and then the number, and then, yeah, basically, there's a couple technicalities I didn't really specify. Right, did someone want to explain it?
Oh yeah.
Yeah,
So,
go ahead.
the function is f of x equals the number of sloths, which is less than x years old. So the domain is all the non-negative real numbers because age can't be negative. And
Wait, yeah, sorry, I forgot to specify that the years have to be like integers.
oh, okay.
Yeah, that's my bad.
And the range is the set of all non-negative integers because you can't have a fraction of a sloth. And the codomain would be considered all the natural numbers, but it could also be the set of real numbers if you wanted to allow for fractional sloths, but that's not really realistic. So it would be natural numbers.
Yeah, the codomain would be natural numbers, but the range would be like only the set of numbers that are achieved by fx. For example, if there's like 100 sloths less than 1 years old and 200 sloths less than 2 years old, it'd be just like 100 and 200.
Yeah.
Yeah. So the codomain, um, so the codomain is usually given with your function, but since we're usually looking at like polynomial functions, usually the codomain is all real numbers. For example, like when you graph it, you usually graph the y-axis as like all real numbers, like negative infinity to infinity, right? For this problem, it's not like a mathematical function, so technically I should have been the one to give you the codomain, but yeah, the problem is like to see what a reasonable codomain would be.
Yeah.
And then the range is like,
It would be the real numbers. I mean, natural numbers.
yeah. So like, for example, if it was a mathematical function and you graphed it, the range would only be the set of like y points that you would actually reach. For example, if you graph like fx equals absolute value of x, then the function wouldn't reach negative y, so then the range would only be like non-negative, right? But actually, I should probably like graph this. Let me see. Okay, so if you have like, oh, that's the, if you have like fx equals x squared, for example, that's like a parabola, right? Like this. So when you graph it, you graph like the y-axis as positive infinity to negative infinity, but none of the points on the parabola reach like this negative y-axis area. So the codomain would be negative infinity to infinity, so like all real numbers, but the range would only be 0 to infinity because only this top area of the y-axis is reached. So like that's basically the difference between codomain and range. And then, so for our purposes, the codomain is usually all real numbers, but for some functions, if they can specify the codomain as just 0 to infinity, in which case the codomain and range would be different. But yeah. Does that make more sense?
Yeah.
Unless it's specified, is codomain always real numbers?
Um, for our purposes, yes, because we're only looking at polynomial functions. But usually if they just give you like a function and they don't specify the codomain, that's not actually considered like a complete function definition. Like if they only give you fx and they don't tell you what the function is, that wouldn't be considered a complete function, right? Because you don't know what the function is. And then similarly, if they don't give you the domain and codomain, that's also not considered a complete function. But for our purposes, since we're only looking at polynomial functions, then yeah, the codomain can just be assumed to be all real numbers. So like in your homework problems and stuff, you can just assume it's all real numbers. Okay, are there any more questions, or I can go over problem 2? So for problem 2, it's like similar to what I just graphed, right? So the domain is all real numbers because you can plug in all x for negative infinity to infinity. Like you can plug in any x from that set. So it's just all real numbers. And then the codomain is like, for example, it's just all real numbers because it's a polynomial function. And then the range, actually, the range, this is like a separate one from above. So this is like the standard shape for a polynomial, right? But this is for x squared, but our function is x squared plus 3. So it'll be shifted up 3. So like if you consider the lowest possible x squared is 0, so if it's 0 here plus 3, then the lowest y value that we can reach is like 3. So then the range would be from 3 to infinity, including 3. Does that make sense? Okay, then we can move on to 3 and 4. Did anyone want to explain it?
Yeah.
Okay, yeah, go ahead.
So for question 3, we have to find what is f of gx. So we know that gx is x minus 5. So now that we have our x value for f of x, we just input that in. So that means x minus 5 squared. So now we solve. So x, and then we get x squared minus 10x plus 25. And that's f of gx. That's the answer to that one.
Yeah, it is. So let me just type it up. So first you do like gx, right? So gx equals x minus 5. And then so when you have f of g of x, so like this inside thing is g of x, but g of x is the same as x minus 5. So they're interchangeable. So instead of f of g of x, then we just put f of x minus 5 because x minus 5 is the same as g of x. And then if you put that in, then you get it's equal to x minus 5 squared. So that's how we like combine the functions, right?
Yeah.
And then basically you just simplify that into x squared minus 10x plus 25. So then that's your final answer. Right?
Yeah.
Yeah.
And then for number 4, we have to find what is f of x. So we know
Can I
that
explain number 4?
Oh, sure, yeah, go ahead.
okay.
Sorry.
So the function f of x equals x squared plus 3. So then since it's f of x, then that would be x squared plus 3 to the power of 2 plus 3. So then it would equal x to the power of 4 plus 6x squared plus 9, then plus 3, so it would be plus 12.
Yeah, exactly. So it's like similar to what we just did. So we have the definition of f of x equals x squared plus 3, right? So it doesn't matter if you combine two different functions, or you can combine the same function. So basically, f of this inner f of x, this inner f of x is the same as x squared plus 3. So we can just replace that, right? Because we have this inside stuff here is the same as this inside stuff here. And then we just plug that in as x. So then this would be x squared plus 3. Then this entire thing would be squared plus 3, because that's the definition of f of x. And then you just simplify that. You get x to the 4 plus 6x squared plus 9, and then plus the extra 3 at the end. Because like this is the squared. And then you just get x to the 4 plus 6x squared plus 12 as your final answer. Yeah, that's correct. Are there any questions on these two? Okay, if not, we can talk about the last problem. Yeah, did anyone want to like give a guess or explain it?
Yeah, if nobody else wants to.
Sorry?
I can explain it.
Oh yeah, go ahead.
So what I think is that I think the answer is yes. And how I would explain this is I kind of use like the graph you showed us before. So one function could be, let's say f of x equals something, then g of x equals something else, and j of x equals something else. So we could combine all three and we could write it as j of g of f of x, and then you would just input each. So whatever you have for f of x, you would input that in as the x value for g of x, and once you solve that, you would input that for the x value of j of x.
Yeah, exactly. So we can do a composition of three functions, and actually we can do a composition of infinitely many functions as long as like the domain and range are compatible, right? So basically, there's nothing really special about just f of g of x. If we have like another function, j of x, right? That's what you said. Like, there's no reason why we can't do f of g of j of x, right? And then similarly, there's another cool thing you guys might see if you guys go on to do like functional equations or anything in comp math. It's like you can have like, for example, f of x. I don't know how. Like this is like a perfectly fine function, right? And then you can have like f to the like you can have infinite many of these, right? These are all like fine functions because a function is just a machine, right? As long as that input is valid, then it'll give you an output. And it doesn't matter how many machines you put that output into, as long as you still get an output, it's like perfectly acceptable. Does that make sense? Okay, are there any last questions? If not, I think we can end a bit early. The homework will probably be posted like tomorrow evening, and then the recording will also be. If there are no other questions, I think we can be done. Good night.
Bye. Thank you.
Bye.
Bye, have a nice day.
Mhm.
Bye.
Good night.
Thank you.
Bye. Thank you.